So, hello everyone. Today I'll be presenting in front of you my Django-based travel bookings application, which is made on Django, a framework of Python, and on Cloud9 environment. So, I'll be presenting to you right in front. Now, as you can see, this is my application. So, it's a travel bookings application, which is deployed on Elastic Beanstalk. And as it says, let's plan your tour. So the entire idea behind travel booking application was to enable the users to have a control over their bookings and manage them from anytime and anywhere, and also to provide a all-in-one platform where the user can create, read, view, and like update, delete all his bookings without any hassle. I've integrated some of the AWS cloud services along with a Python-based library in this application, which I'll be uh, coming around in this video further. So to begin with, I'll start with the first service, that is the AWS RDS, which is a relational database system, which is used over here. So over here, when I click to book now, so as soon as the user clicks here, it will take him to a page where all his bookings will be viewed. So it has a list of all the bookings made by the user. So right now we have 3 of them. If I click on any of them, so it takes me to the page where the details of the bookings are presented. So it says it's by Kenny on for 10 people to Cork on 6th January, right? And it has options to edit, delete, and back to list. So if I have to edit it, say I edit the people from 10 to 11 and I save it. So we can see the details have been edited and updated. Now, if I go back to list and if the user wants to make a new booking, so he can click on the add another booking and let's enter a name, say Pani, and number of persons, say 8, and default destination, we will have Galway. And let's keep the date as it is. When I save it, so we can see a new booking has been created. When I go back to list, instead of 3, now I have a 4th booking, which is the most recent one and at the bottom. Now, coming to the code, it's in Django, which makes use of a MVT structure, which is a model view template structure. For each of the views, we have URLs. In the URLs, we have the URLs defined. So, for example, here, for each of the view, I have a URL defined. Now, we have models where for each of the fields, we have exactly the same field which is displayed over here. As you can see, name, number of person, destination, date. And it's the same for the form, which is called item form, and name, number of person, destination, and date. And by default, this Django makes use of SQLite database, but since we're using AWS RDS, so over here, we have the AWS RDS database name along with the engine, which is the Postgres. Now, coming back to my application, if I go to cancel, now, if I have to delete an entity, suppose I need to delete this one. So I click on delete, and now we can see in place of the 4 bookings, we only have 3 left. So that's how the entire CRUD works in this travel bookings application, where the user can easily perform CRUD on his or her application. And the in the views file, we have the CRUD each specific CRUD for like detailing and then adding a new user, editing it, and then deleting. So for each of them, we have specified the functions in the views file. Now, talking about the next AWS cloud service that I've used in my application is inside this My Docs folder. So when I go to this, the user can use this to save his or her travel related documents, tickets, PDFs, etc. Here, I've implemented the AWS S3, which will store the objects, which is the PDFs and images, etc., in the buckets. So when I choose file and I click on any of the files, say 81, and then I upload it, it takes me to successfully uploaded. And now when I check it on my S3 and I refresh it, so inside my transportation one bucket, I have the object 81.png added successfully. Now, if I have to delete it, I could suppose I want to delete 83.png. I can click on delete. It says image deleted successfully. And when I go to S3 and I refresh it, now I see that object has been deleted from the bucket and it's no longer here. So talking about the code, so it's again in the views.py file where we have implemented the request.method is equal to post, then check if the delete button is clicked, and then the deleting the image from the S3 bucket and returning specific HTTP responses on deletion and similarly on the updation, right? And then rendering the specific HTML pages, which you'll find over here, these HTML pages. So that's where we've used the AWS S3 to store users' travel related documents that he could access from anywhere, anytime. Now, the other service I've used is the AWS SNS over the subscribe portal, where the user will enter his or her valid email address that would contain an @ sign. And to that email address, be sending the subscription mails. So I'll enter mine and then click on subscribe. It says successful. Now, when I go to my Gmail, now you can see I've received AWS notification confirmation subscription, right? Just now. So that was the purpose of AWS SNS. And when I look at here, you can see the subscription confirmed and through email. Now, likewise, going back to my application, apart from all these AWS web services that have been implemented here and the one as well, it's in the views.py file where we are getting the email address from the form and we are validating the email address, subscribing to the topic, and then checking the particular HTTP responses for successful subscription that we just saw right now. Now, apart from this, coming back to my application, when I click on the click here to book now, I find a click here to find which vehicle fits you best. This is basically a library implemented in Python, which would recommend the user based on the group size of the people traveling a particular vehicle for their travel. So when I click here and the user enters his or her name and enters the group size of the people traveling and submit it, under the travel recommendations, he or she will find the recommend. So we recommend using a car for your travel. Similarly, if the user puts in the number, say 8, and submits, so now it recommends a van for the travel. And likewise, for each group size, it will recommend a different vehicle. So this way, it reduces the complex, uh, complex complications of the users to decide which vehicle would suit them best. So that's where this library finds its use, by just recommending a vehicle based on the group size of the people traveling. Now, coming to the most interesting aspect of my project is that, before that, yeah, this has been deployed on Elastic Beanstalks, and you can find the domain here. Now, coming to the most interesting aspect uh, of the project is that the approach to the travel bookings and how different various AWS services have been used for robustness and scalability, and a, a library that is a recommendation system and enhances the user experience for the personalized suggestions based on the number of people traveling. So for me, the interesting part was the library, and of course, how various AWS services have been implemented together to increase user experience, robustness, and scalability. So this was it for the project. Thank you.